Hello, everybody. I am Shubhranshu Bose. I'm working 20 years in a manufacturing company at various department of analytics. Can I audible? Hello.
Yeah, you are audible.
Okay.
You can turn on video also for sound.
Okay. Okay. Yes. I'm working in manufacturing company for 20 years. Now I'm worked as the president works in Aditya Dance Wings Private Limited. I have different types of knowledge in analytics, machine learning or AI tools. I used for a long time, from 2012. I'm working already in this field. I passed intake from Jadavpur University and PGDM from IIM Calcutta, and I passed MSc from Liverpool Journal University from UK. Today I start on the style transfer using generative adversarial network. GAN, abbreviation is GAN, generative adversarial network. What is the utilities of this GAN? GAN is basically based on convolution neural networking. Before analyzing the GAN, before analyzing the GAN theory, we should know the neural networking, because neural networking is the basic tools to analyze, any image, any picture through this model, generative adversarial network. First, I'm giving some introduction of these tools. There are various types of MRI. Here, the picture is basically MRI of brain. The left side is type 1, T1, and the right side is T2. One type of MRI may not be sufficient in capturing particular type of abnormalities, because there is some component: fat, water, tumor cells, bones, cartilage, etc., etc., etc. That's why to analyze any abnormalities, or to find any abnormalities, we should take different numbers of MRI. Then we can find any problem in the brain. Having another type of MRI may enhance the accuracy of diagnosis, thus leading to better treatment of the patient. However, gaining access to different imaging techniques is difficult and expensive. Also, doctors often prescribe one type of MRI at once. But if you would create another type of MRI from one that we already have, moreover, without investing the same amount of money and time. In this case, generative adversarial network system provides a solution. If we have one picture of MRI, we can create many pictures from one picture. In this case, we have no need to different MRI pictures. one for poor patient or poverty level. That's why there is main MRI cost is 5,000 to 6,000 per image. If we take 5 or 6 or 7 MRI, then it is 30,000, 35,000 MRI for brain, in case of brain. But in this, using these gun tools, we can create different 2 or 3 or 4 MRI images from one image. It lowers the cost. T1, left side picture. See the left side picture. There is the MRI, real MRI picture. There is no find any direct tumor cells. Just one notch at the right side, and it cannot inference any conclusions. But through this picture, we can create T2, this right side picture. See this picture, right side of the picture T2, there is some tumor cells. This is the utility of guns. And then we can predict the patient's health. Another example. There is one utility of gun. Another utility. If we image transfer, if we want to convert the apple's color from red to orange, red to yellow, dimension, keeping dimension same, just color change is possible through this technique. Different type of fruit is given here. If we want to change the image from zebra to horse or vice versa, also horse to zebra, see this image. One is real. This horse is real, right side, left side. But this zebra is AI generated zebra from this horse. It is also utilities of gun. Gun is used for generating various kinds of data, be it its image, videos, audio, etc. When you use it for specific use case, we make some variations in basic gun architecture to obtain better result. Some of the specific use case, solving guns, fashion gun. Fashion gun means when we just convert, keeping the actor, actress, same picture, but its uniform can be changed from through the colors or different styles. That is used in fashion guns. And fashion technology, in fashion technologies, we already use it. The style gun is also this kind of gun. It's just haircut. We want to change the haircut through the picture, keeping the same man, same woman. We can use this gun. Now, what type of, how many type of gun can be used? First, today we analyze the DC gun. DC gun means direct convolution generative adversary network. Here, that convolution network, neural network, CNN, is used to create new image, to analyze that image, to create a new image. This is called convolution neural network. The cycle gun, another type of gun. Here, we used mainly the convolution neural network, but there is some difference to take the convolution CNN model. That CNN, there are two types of CNN model is formed. One upgrading or downgrading. Next, after some time, I will describe this structure. Other than that, DC gun or cycle gun, there is Gau gun, style gun, fashion gun. If there is various types of gun which in used in the industry. Now the architecture of the gun. What type of architecture? In gun generative adversary networking, two agent, there is two major component. One generator and other one discriminator. What is the role of generator? Generator creates the new image from any noise or scratch. Generator create the new image from the noise or scratch. Now, what is the role of discriminator? The role of discriminator is basically is a pollution. Discriminator identify the generator's generated image is fake or true. Discriminator just identify and recognize the which one is true or which one is fake. The role of generator is like a thief to generate the fake samples based on the original sample and make the discriminator fool to understand the fake as real. On the other hand, a discriminator is like a police whose role is to identify the abnormalities in the samples created by generator and classify them as fake or real. This competition between both components goes on until the level of perfection is achieved, where generator wins, making a discriminator fool on the fake data. Basically, this is the more fundamental architecture of the gun. One generator model and other one discriminator model. Generator model is a CNN model, neural networking model, and discriminator is also another CNN model. There, in gun, there is two type of CNN model is functioning. One for generator, create the new image or fake image. Other one to identify the fake or real for the discriminator network. Discriminator CNN model. This one, generator and discriminator. Just see the picture here. Noise, the input of the generator, random noise, that create a new image that is fake or real, just fake image, and that goes to the discriminator, and discriminator trained by the real image, and then comparing the trained real image with this fake image, discriminator predict the real or fake. Basically, binary classification, on or zero. One is real, zero is fake. Discriminator mainly they classify binary in binary ways. And generator neural networking, generator model create one image. Generator. One thing is important for generator. It is unsupervised learning approach. Why? Because generator creates the image from the scratch or from the random noise. That's why generator initially is initially use the unsupervised learning approach. In case of supervised learning approach, generator get actual picture, but in this case, generator cannot get an actual picture. Generator get some random picture, random data that is called also noise, and from the noise generator create one image that is fake or real, that's whatever it is, but create a new image. After discriminator, when discriminator just predict its result, real or fake, through this prediction, generator, this prediction from the discriminator backpropagated to generator. And with this information, generator again trained and then create another data, another image. And it is also analyzed by discriminator, and discriminator gives some prediction. If it is fake, then this fake information backpropagated to again generator, and generator is again trained. That iteration is going on when generator still till that time, when generator create a new image and discriminator cannot find any wrong in it, and discriminator then predict it is real. Basically, discriminator is becoming full to understand the generator's image. This one is another layout, generator architecture, latent space, where we find some input noise, generator image, and again discriminator to real or fake. Discriminator classify the binary classification, real or fake, and discriminator is trained through the data set, real data set, with the comparing the real and the generator's image. Discriminator can say which one is real or fake. Then the simple DC gun, the gun model is DC gun, direct convolution gun. Most simply, there is some after this one. Random input generator to sample. Sample means fake image, created image. Go to discriminator, predict something. It is called loss. If it is predict false, then loss value is generated. This loss value backpropagated to generator system again, and again create a sample or image, again loss value, and loss value will be minimized with the time, with the iteration, continuous iteration. This is generator training or discriminator training. What is this discriminator training? Discriminator training, it is called generator loss. Discriminator training, when discriminator fails to predict actual figure, actual real image, that is called discriminator loss. When discriminator fails to actual real image, that is called discriminator loss. This discriminator loss go to his backpropagated to its neural network and trained, and then again iteration is continued till these losses will be minimized. This is the total technique of DC gun or any type of gun. Just generative adversarial network guns, just step one, noise vector, create fake image, authentic image mixed with synthetic ones, train discriminators on mixed set, train and again generate noise vectors, but label them real, and train gun using noise vector label the real image. This discriminator generated data, first picture, 10 rupees. It is fake. Real, this one is real. It's fake. Again, it is also fake. Then last one, it is near about real, and discriminator failed to identify the real and fake, and it labels as real. Then we want to know, see, understanding, we should know about the loss function of term. What is the loss function? How can it is calculated? Say, loss function, there is two loss functions that are connected to discriminator. During discriminator training, how can we train the discriminator? Through the real picture. How the generative will be trained? Through the predicted discriminator's result. Through the discriminator's result. Or discriminator training through the real picture. During there is two types of loss. One is discriminator loss, or other one is generator loss. Discriminator training, you should not consider the generator parameters such as weight, biases, generator loss. The discriminator classifies both the real data and fake data from the generator. Discriminator loss penalizes the discriminator for misclassifying a real instance as fake or a fake instance as real. What is discriminator loss? This can penalize the discriminator of misclassifying a real instance as fake or a fake instance as real. What is our goal? Our goal, to maximize the discriminator's losses. Why? If we maximize the discriminator losses, we can easily fool the discriminator by misclassifying a real instance as fake or fake instance as real. This is our, in case of discriminator, our role to discriminator loss should be maximized with the time. But in case of generator loss, our aim to minimize the loss. There is a beauty. Two loss. We want one loss should be minimized and other loss should be maximized. The total, what is the total? Total is the multiplication product of the two loss. That is the total. The total value will be the minimum. The weight of the discriminator are updated through the back propagation from the discriminator loss through the discriminator network. That is shown already in this case. Discriminator loss, this loss put back propagated to discriminator network and then trained, and another algorithm is generated, and another findings will be found next at the next case of the generator. Okay. Real image train the discriminator network. Real image prediction train the discriminator network, and fake image prediction by the discriminator train the generator network. The loss of generator, when generator loss, what is the generator loss? Just see. This is generator loss is when we generator create a image, fake image means 0, real image means 1, and discriminator analyze it and predict it is 0. But For the case of generator, that fake image is basically 1. And for the discriminator, it is 0. Basically, it is basically fake. That's why the 1 and 0, that creates a loss of generator network. In case of discriminator network, what is the loss of discriminator? Well, a real image is the input of discriminator, and discriminator predict it as a fake. Then same 1 is the real, input is real 1, but predict is 0. That creates another discriminator loss. So 2 type of. Then we go to total loss. This is our objective is basically maximize the discriminator. This is discriminator loss. LD means loss of discriminator. Maximize the log dx. Log dx means y predicted plus of log 1 minus dgj. It is also y predicted. It is a formula. Just you read some tensor analysis book and you get some definition of this. It is not so much important for making the algorithm. It is a discriminator loss, or this is such a generator loss. I want to minimize it. Just mean log of 1 minus dgx. Objective of generator is to fool the discriminator. So it tries to minimize the above loss. What is called earlier. So it tries to minimize the above loss. But remember that during the generator training, the discriminator is frozen. And y equal to 1 real data is not provided. Thus, log dx terms vanishes from above loss. And therefore, the final loss function generator can be given as this. When training the discriminator, generator training will be frozen, and vice versa is also true. When the training the generator data, generator networking, and then discriminator network will be frozen. One is open and other is off. Another is on and other one is off. This process is running here. Then we understand how to make a neural network, convolution neural network in generator and discriminator. It should be this one. First, this is a networking architecture, convolution neural network architecture. Here, this is input. This is input 1. And then one step where 124 is a channel and 4 and 4 is a width and height. And convolution 1, after convolution 1, height and width will be increased, but channel will be decreased. And then 2, height 16, 16, and 256, 5, 1, 2, 2, 256, 32, 32, 128, and then channel is minimized, and height and width is increased. This is the opposite of convolution neural CNN. This is basically transpose convolution network. Trans CNN. In case of convolution neural network, we increase the channel and height and width will be reduced. But in this case, height and width will increase and channel will be reduced. Because we make on image for other case in CNN, their analysis is necessary. there is no creation of new thing. But in gun theory, creation of one new image. That's why we want to reduce the channel and height and width will be increased. One example is this one. MNIST digit generation. MNIST is a spreadsheet, basically is a block where different type of numbers are stored. This is a raw data set, MNIST digit raw data set. From MNIST digit, we want to create a new digit through using DCGAN, direct convolution generative adversarial network. How to make algorithm? What is steps? First, import the libraries. Then data loading and visualization. Data loading and visualization means MNIST data. Basically, it already get in the internet, Google. Data loading and visualization. How to visualize? It should be seen. Data pre-processing. Then model building. Then model training. Model training means generator training or discriminator training. And then generating GIF of new generated image. This is the 6 steps. We need libraries, NumPy, TensorFlow, Matplotlib, and Scale. Using the basically TensorFlow. Import TensorFlow, import Matplotlib, PyPlot, Globe, and SKImage for transforming image and resize. Import resize, NumPy, and all data will be analyzed. Basically, all library from the Keras utilities visitors. Data loading and visualization. Data loading, MNIST data loading, train images, train labels, and TF Keras datasets MNIST load data. Here should be noticed the train image and train labels. It is necessary. Labels is very necessary. Which is 1, which is 2, which is 3, which is 5, which is 6, the integer. Label is basically necessary. That's why train image and train labels. First, loading is done with the labeling and then visualize it. Just figure size 2 by 2. Imhow train images 0. Grayscale, that is grayscale, axis of and plot 5. This one. This image, there is lots of images, of crores of images, basically, of integer. And image size is different. The first data pick in this case, any image processing case, not for only GAN, image processing case, we should follow the normalization of image, and then resize of image, and then reshape of image, and then shuffle. That's 4 steps is common for all image processing steps. How to normalize? First, I take some amount of image, not the full, because poor RAM, that is not possible to process all data. Our buffer size is 60,000, batch size is 2048. batch size 2048 means 2048 number of image from 60,000. We take 2048 image from 60,000 and noise dimension 100. It is standard noise dimension for GPU processing. And then pixel normalization to zero center, -1 to +1, +1. All 2048 image will be normalized within the -1 to +1. How? The train data set equal to train images by 127.5 -1. 127.5, what is it? 127.5 means 255, 0 to 255 pixel. That's the size of the all image. 127.5 is 0. And 0 to 127.5 is 1. And 0 to -127.5 is -1. That's a -1, 2 + 1. That's the range. What is the rule? Train image. It may be 240, 230, 200 by 127.5 -1. It is the value. This value will be the -1 to +1. The normalization image first. Then resize the image to size 32/30. This standard size 32 by 32. How? NP0's buffer size 32 by 32. Buffer size means this is the 60,000 images within the 32 by 32. Train images, resize 32 by 32. Then plot it, plot figure, just to show our normalization process. See the picture, there is no axis, -1 to 0. It's -1 to +1 is dimension, axis off, no axis, and then reshape image to add channels dimension. Now we add the channel dimension, train image, reshape 32, 32, one channel, single channel. We see, we use this one, input. Channel is one, sorry, output. We make to, when we can create a new image, or channel will be 1. But input will be higher channel. Let's see. 1. Shuffle data. All batch or 2048 images should be shuffled. And then train data. Seed 42. Batch size means 2048. Number of images. Then model building. How to generate a model? Build a generator model. 2 model will be generated. One is generator model and another is discriminator model. First, I discussed on the generator model. Model the TF sequential. Sequential means iteration is necessary here. First layer 4 into 4 into 128, and second layer 4 into 3 for 128 3 by 3, third 64 3 by 3, and 1 3. Just channel is reduced here. Channel is reduced, but height and width is okay. There's this one. Say one model 4 4 128, 8 8 128, 16, 16, 164, 16, 16, 64, just height and width increased and channel is reduced to 1, 32, 32, 1. Last convolution network, see input 16, 16, 64 and output is 32, 32, 1. Height and width is increased, channel is reduced. Our channel, at first our channel was 2048 and it went to 1. Our first height and width 4 into 4, 4 cross 4, and that is convert to 32 into 32. That is this generator models. Then model at TF keras layer, first 4 into 4 into 128, batch normalization and activation leaky ReLU. I use leaky ReLU activation. And then reshape again and conv 2D transpose. That is a conv 2D, just I described the convolution to neural network transpose type. That is different from the CNN, general CNN model. Already I discussed it. What is the difference between general CNN model and transpose CNN model? There is a big difference. In general CNN model, our input channel number is minimum and maximum output channel number is maximum. Means channel number is increased towards with the time, with the layers. But in case of transpose CNN model, channel number is reduced with the layers. That is the big difference. Another difference is height and width. Height and width is in CNN case, height and width is reduced with the layer. But in case of transpose CNN, height and width is increased. What is already I have discussed here, but why we need transpose CNN for the GAN? Because GAN create a new picture. GAN cannot analyze the picture. The purpose of GAN is create a new picture. Purpose of generator models create a new picture. So that's why new. If we in other image processing technique where CNN model is used, there need basically the analyzing the pictures. Their channel can be increased, height and width can be decreased, but in case of we create a new image, their channel will be 1 because it is one-dimensional, two-dimensional picture, but height and width will be important here. That's why, and we use the leaky ReLU activation function, and after layer formation, then batch normalization is necessary, and then activation function, then another third layer, same 64/3/3 batch normalization, leaky ReLU, and last in all case padding is same. Activation tan H, in last case activation is tan H, not leaky ReLU. Last tan H means this one. Input output, new image, always. Generate image through a raw model. In this case, we create a new, we create a CNN model of generator, but still we can't train the CNN model. That's why if this model is used for a new image, we can find this type of noise image. This generator, without trained generator, cannot form an actual picture. But it's the structure of the algorithm. After training, it can create. After training, generator gets a uh, new information, new data, and it can create a good data, a good picture. Okay. Then we make a discriminator model. What is the discriminator model? There is some difference between generator model and discriminator model. What is the difference? Generator model create a new picture, but discriminator model analyze it. That's why here transpose convolution network convolution CNN model is no required for discriminator model. Here convolution CNN model is required. Here just see, just structure. Okay. We input TF Keras sequential is the primary algo of the ME CNN model, and then convo to 16 3x3 strides on bias false 32 by 32 1 image shape, that is 32 pixel one channel a dimension, sorry. Relu and leaky relu is the activation function, and then next step 32 to 64, 64 to 128, 124 to 256. That's the process. The channel number is increasing. That's why it is convolution 2D, not convolution 2D transpose. But for the case of generator, it is conv 2D transpose. It is conv 2D. Okay, and leaky relu is the is its activation function, and then model 2D 1 10 10 just to analyze the 2D picture. It is the architecture and decision equal to discriminator generated image and print a decision. What is the decision of this picture? This picture is a Kawak picture, noise-based picture. TF tensor 0.001215. If it is 1, then it is real, and if it is below 1, that is fake, and it is very much below 1, and completely ignored this picture. We can completely ignore this picture. Its value is this one, because this generator has no training, and discriminator has also not any training. Both have required training. Then model training. Their model training. How to train the model, discriminator model and generator model. In the GAN, training start with the loss function. Through the loss function, training started at generator CNN or discriminator CNN. How to measure this? It is measured through BCE value. BCE loss means binary cross entropy loss function. Because it is binary function, basically 1 and 0, predict the value of the discriminator. It has classified the result through the binary system 1 or 0, not the multiple system, the binary system 1 and 0, not a ternary quaternary system. And cross entropy is a Keras losses binary cross entropy for logic true. Calculate the discriminator loss on the real data. Just see the picture. Noise generator creates a fake sample d dash, y equal to 0, y equal to 1 real sample. The discriminator basically. Discriminator predict the value y equal to 0 or y equal to 1 if it if it gives y equal to 1, then if fake value prediction is will be 1, then the loss penalize discriminator penalize the loss, and it back propagated to discriminator, and again training is the after training again discriminator analyze the next sample, and iteration is going on epoch by epoch. In same way, when real sample is predicted at fake sample is predicted at 1, it is fake, then that loss function will be back propagated to generator, and generator will be trained, and then create a new sample till the discriminator give the result 1. This is a loss of real data, loss of fake data. Yes. This one. After training, discriminator loss, real input, fake output, real output, fake output, real loss. What is real loss? Real output. Fake loss. What is fake loss? Fake loss means real loss or fake loss. Fake loss is fake output. Fake output means real output when real sample is predicted wrong, then it is real loss. When fake sample is predicted wrong, that is fake loss. That will be back propagated to discriminator network. That is called discriminator losses. And generator losses, same way, the only fake, there is no need of real loss, there is need the fake output. Just generator wants to fool the discriminator, that's why fake output is the important for generator loss. Then Adam optimal. It is very common optimizer for optimization process algorithm for the gun. It is used for epoch training, iteration, continuous create a new image and predict its prediction, and through the prediction, again training is incorporated in the generator and also in the discriminator, and again create a new sample, new image, and this training is going on epoch by epoch. This optimization process is Adam optimizer. It is used as a generator optimizer and discriminator optimizer. The training will train our 250 epochs. Epochs equal to 250, I consider. And checkpoint. It is very necessary. Checkpoint. What is the checkpoint? Checkpoint means at every epoch we want to store the image. At every epoch, step by step, we want to store the image. We should store the image, basically. Then we understand the actual training procedure, training process, how to improve the training from one epoch to another image, and then another epoch. It should be known. Should be stored in the initial OS. That's if not OS path in generated image, and MK generated image. It is stored it. This one. This is very important. And training flow. What is the training flow? Training flow, the Basic conception, generator loss and discriminator loss, and there's go to back propagated to discriminator and generator. And this loss, how to, which value is back propagated from prediction to generator or prediction to discriminator, which value? This is called gradient. We want to convert the loss into gradient. This one, this first TF gradient tape, all gradient of generator, gradient of discriminator. We want gradient of generator and gradients of discriminator. How can it? Generator loss, we calculate the gradient. Gradients of generator, chain type, gradient, chain loss, generator, trainable values. Trainable variables, through the trainable variables, which loss is in, what loss is incurred by the generator is converted to gradient in form of gradient value. Same as gradient of discriminator. This gradient value is important because gradient value trains the model, generator model and discriminator model. Gradient value back propagated to generator network and varies the trainable variables and generate a new image. To calculate the gradient and apply gradient in the optimizer. This is generator optimizer dot apply gradient chip. What is mean? Apply the gradient in the optimizer. What is meaning of it? This is from Adam optimizer. This Adam optimizer can recognize only the gradient value of any prediction and this gradient value first change the trainable variables and create a new image through the Adam optimizer. That's why it is very important. Adam optimizer is the main tools to train the model. Several epochs. Epochs plus one means one epoch to another epochs, next to next, next by next. And we ultimately find after 50 or 60 or 70 or 250 epochs, we can find a new image that's near about the real image, near to the real image. This and generating the GF generating image and file it and store it. This embed file and in file this 9 near about 9 8 8 9 9 2 9 9 all are like a real. This is GCGA. After GCGA, we analyze another gun system, the cycle gun, image to image translation. See this picture. Image to image translation is of two types based on the type of data, paired and unpaired. See this. This one labels to factory. This house just get one picture input and output this one. The paired data. Paired data means natural mapping is possible when input and output image, or you have the exact mapped output image available for each input image. This input labels of street scene, just car, picture of car, and then real output. Paired. This one, input, bag, just drawing of bag, sketches of bag, to real bag, output. This is a paired data. Same dimension, same thing, but it looks real through the color, through the other dimensions. This is called pix-to-pix architecture also. Unpaired data, very important. Unpaired data, that is unpaired data. Horse to zebra, unpaired. Zebra to horse, summer to winter, winter to, we get a winter picture and we convert to summer picture. We get a horse picture, we convert to zebra picture. This is the unpaired data. Unpaired data is also called independent data, where there is no unique relationship between input image and output image. For example, let's consider the horse to zebra style transfer. There a direct mapping is not possible because a horse cannot simultaneously exist as a zebra, but vice versa. Another similar example is weather translation of image, where a place cannot experience two different kinds of weather at the same time. Suppose there is a tree in an image. This one, summer to winter, weather translation, winter to summer, weather translation. And suppose there is a tree in an image, just see the tree. It looks like it as weather changes. In autumn, there would be fewer leaves. The leaves might have a reddish shade in summer. In winter, same tree might appear hazy due to fog. Each image of the tree may have different feature, thus showing the different weather condition. It is unpaired model, unpaired data system. And this is paired data. For paired data, we use generally pix-to-pix architecture to analyze it later. For unpaired case, cycle gun, dual gun, disco gun, there is number of gun and the fashion gang also. We add cycle gun. This is unpaired. For unpaired, what is cycle? Overview and application. What is cycle gun? Very interesting technique. For unpaired case, for unpaired images, what is our goal? Our goal is to generate a image of new domain from another domain. What is it? Generate an image of a new domain from another domain. Zebra to horse. Zebra is and horse, domain of zebra and horse is different. Apple to orange, different domain. Summer to winter, different domain. There is an unpaired condition. But paired condition, there is same sketch converts to the real one. This is butterfly, white butterfly, just change its color. This is paired data. In case of cycle GAN or unpaired case, unpaired data system, our main focus to generate an image of a domain from another domain. But question is, what enables is generated to create image of a domain from another domain? Let's see that. Hello. Just see this networking, neural network system. This architecture, UNet architecture. Input image, this is input image, where it's 572 cross 570. First one channel, then it is 64 channel. 57 to 70, 568 into 68. See, width and height is reduced, channel is increased. Then next, 284, again 284, 568 to 284, 282, 280. Again, width and height is reduced, but channel is increased. 256, 128 to 256, and then 5 to 12, second, third layer, fourth layer, first, second, third layer. Then single, 1024, just one the maximum embedded value. There is downgradation, 5672 cross file 72 to 1 into 1 downgradation, and then again upgradation 1024 to 2 value 2. It's 2 network, one transpose CNN and direct CNN. Both are used in cycle GAN architecture. Cycle GAN architecture. First, compress the image and extract the all features of the image in 1024. This one. Channels is high. Extract all features. Channels is high means extract all features and compress it, and then develop, regenerate a new one, new domain through these features. New domain. Just compressed it, compress the image and regenerate it. Downgradation and upgradation. So the functionality of generator changes DC GAN to cycle GAN. DC GAN will create image from one-dimensional noise input, whereas cycle GAN, our aim is to generate image from different domains of the image. Image to image translation. That one is downgradation or downsampling, and second step is upsampling. First, downsampling means width and height is reduced, and upsampling, width and height are increased. But channel is, in case of first case, channel is increased, downsampling, and for upsampling, channel is decreased to 1 or 2. There is also direct connection of layers of unsampling and downsampling, as you can see. The skips connection. Skip, what is the use of this skip? This is skip, this arrow side, from there to there to there. Yes, there. What is the requirement? If one apple, we want one image of apple convert to a orange, we need the total information of apple. That's why all data from the apple is quenched, but there is no required the information quench of the boundary of the apple, environment of the apple. Say, this one. We want this picture quench, sampling or downsampling. But we do not need this grash outside region. That's why outside background is same for both cases. That's why this skip, background skip from one layer to another layer. For background skip system exists in cycle GAN. That's why it is cyclic. There is a connection called skip connection. Their connections ensure the transfer of static component of the image, such as background. This is static component. There is no need to change from this one to this one. To understand the same, have a look at the below picture. Notice that background is not changing. Hence, we can map it directly using skip connection. Then, we want to know architecture. What is the cycle GAN architecture? Cycle GAN has two parts. One generator and another one is distributor. Same. but there is some differences. Generator is very important in this case. A to B transfer, generator GAB, and B to A transfer, generator GB. Just see this diagram. Horse to zebra or zebra to horse. Just discriminator, use of discriminator. Discriminator through the real picture, discriminator correct the generator. This one. X is a one image, input of the generator. X convert to Y predicted, new Y. Y again, Y is the input. Predicted Y is the input of, new Y is the input of F. F is another generator, it's called F, and it convert to X. If any difference is found between X and X bar, then this is called generator loss. This is called generator loss. If same generator, same reverse generator is used for converting Y to X and it finds different X, then this generator has some error, need to more training. And this is called generator loss of cycle gain. This is this one. X to Y and Y to X, a different cycle consistency loss. This is called X to Y and another Y to same X, then cycle consistency loss. Okay. Loss of GAN, DC GAN, or loss of cycle GAN is something different. Loss of cycle GAN, the loss of DC GAN is the summation of generator loss, real loss or fake loss. Here is little different. Here is some little difference. X to Y, generator G, Y to X, generator F. F is the reverse of G. And if any difference between two X's, then loss has been created. Then, in summary, we can conclude as the cycle in each cycle GAN generator is a three system. One is the encoder, and is transformer, and decoder. Encoder, transformer, and decoder. What is encoder? Encoder is first one. Encoder means the input, an input layer, one or two layer. And transformer, what is transformer? Where I quench the all parameters or data from the image, the transformer, and then decoder. It creates a new domain, the decoder. This is the architecture, structure of architecture, of cycle GAN. This is the generator architecture, and discriminator architecture. Same number of channel is increased first in discriminator because discriminator analyze the image. That's why it needs the good number of channels. Let's say first increase 64, 128, 256, 512, and then predict some binary prediction on convolution layer first and normalized ReLU, and sigmoid curve last one. Why sigmoid curve? This is binary classification, 1 or 0. This is the cycle GAN. You can see another. This is 4-9 cycle GAN example algorithm. It is loaded at YouTube. Just see the algorithm. This one structure, upgrading and upsampling and downsampling. Cycle again for discrete generator. And the discriminator, this is discriminated neural network, CNN model. And model training is same, loss value calculations and gradient calculation and back propagation to this CNN model, and then create a new. This all are given here. The good algorithm is very understandable algorithm and very unique algorithm. It is used in various fields directly. Thank you very much. Welcome all of you. I hope you understand the GAN architecture and GAN utilities. And any you have faced any problem, you may contact through mail or SRF. subrangshu@gmail.com. You may face any AI problem. I hope you may contact through mail. Thank you.
Okay, I think some questions or queries is there. Someone raised hands. So please unmute yourself and you may ask your queries. Sneha Misra. She has some query. She raised a question. I don't know whether she is here or not. Snehalata. Snehalata, are you there? Anyone is having questions, you may ask. Feel free.
All algorithm will be given on YouTube, all notebook, and description also given in a YouTube. Just to read this radiology masterclass, something, and this one. Okay. Generative Adversarial Network. Link is given in this words. This one, TensorFlow, a tutorial generative DC GAN. Anyone have question?
I think they are waiting for certificate form. I am sharing you.